You're going to have to forgive me for doing this one a little bit quickly. I've been trying to record it 4 times and it hasn't worked out properly. So I'm going to go a little quick on this one because I need to move on. So problem number 11, we have a car hitting a wall and it gets impacted and bent a little bit. Now here's the thing that I think as a physics teacher. First, problem is that I don't have time and I want, so what am I trying to say? Whenever I see a car smashed into a wall, 90% of the time, the formula is either going to be work is change in kinetic energy, or v squared is u squared plus 2 times a times the distance. Like every single time I see one of these problems, these tends to be it. Every now and then I'll get f delta t is delta p, but I'm not seeing any kind of momentum thing measured here. And the interesting is, you notice how they don't even, they measure the, so again, it's because the word collision's mentioned, I'm going to put down the impulse formula, but I'm not necessarily going to use it. So jumping in here, we're asking about the force, the crush force. So I think I'm going to use this, solve for A, and then F is M times A. So let's try that out. So here we go, using this idea here. V squared is u squared plus 2as. Now here's the thing. V when we hit the wall is the impact speed. But its final speed when it comes to rest is 0. So we end up getting that the acceleration has an absolute value of v squared over 2d when we solve. Because for s, we're going to put in the d that they ask us for. And then the force on the car is going to be m times a, which is m times v squared all over 2d. Now here, they ask us to fill in a table for crush forces. So let's go ahead. When we actually fill in that table, we're going to end up getting a series of values. 0, 0, 113, 286, 346, and 392. I'd calculated these before. And what we want to do is we actually want to plot these. So let's see. Let's try to go up to about 400. So how many? 1, 2, 3, 4, 5, 6, 7. Okay, you know what? So what I'm going to do is I'm going to count by 50. So this will be 100, 200, 300, and 400. And this is going to be v squared over d measured in meters per second squared. And this is going to be v measured in meters per second. And we go up to about 20. So let's just see. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 square. So maybe we could go like 5, 10, 15, and 20 right here. And then we want to put in our values. So 0, 0. At 10, we're at about 286. So 10 is about 250, 60, 70, 80, 86, about right there. At 15, we're at about 346. So it's about a little under 350 right there. And then for 20, we're at about 400, a little under 400. So I'll put that right about there. And we're also told that at 3, so this will be 1, 2, 3 right there. I'm at about 113, so 113 right there. So when I fill in my, this is going to be really bad. That's as close as I can get to a decent curve. So that's what the curve should look like. Now we're told consider the situation in which a car has an impact speed of 12 meters per second. We want to use this to get the force. So the force is mv squared over 2d, but this graph is v squared over d. So to solve this, we're going to need to take f, and then we're going to take m. We're going to take m, divide it by 2, and multiply it by the v squared over d from the graph. So at 12 meters per second, so 11, 12, my force is about 310, right? So, or my v squared over d is about 310. So this is going to be m over 2, which is 1200 times 2 times 310. And so when we actually solve this, we're going to get about, roughly speaking, about 1.8, 1.9 times 10 to the 5th newtons. The acceptable range, they said, was 1.9 to 2.1 times 10 to the 5th newtons. So that's how we're actually solving this problem here. So that's question number 11. Again, sorry to rush. It's taking a long time to get this one done.